Okay, all of you, good afternoon. Good afternoon, friends. So, hello guys, am I audible? Very good afternoon to all of you. Please let me know once. Okay, that's great. Okay, let me first share screen with you, right? What we learned yesterday? Yesterday we learned linked list data structure, right? Then we already started with stack data structure, right? In the yesterday session, we seen concept and definition of stack, as well as we have started with stack applications, right? And we also seen on paper how to convert given infix expression into its equivalent postfix, and given infix expression into its equivalent prefix, right? Now, can we see the algorithm, friends? Can we see the algorithm? Are you ready? Hello, friends. Please reply me once. Are you ready? So, can we start? Okay. Or should we wait for another 2 minutes? Because how many students joined so far? Only 37 students. 37 में से 3 faculty है. Only 34 students joined so far. So should we wait or should start? Because today is last day and we have to complete everything by today itself. Okay. So we'll do one thing. We'll start, right? Okay. Algorithm number 1 is a conversion of given infix expression into its equivalent postfix, right? Okay. So for this algorithm, can you please guys tell me what will be the input? For this algorithm, what will be the input? Yes, what is expected? What is expected input to this algorithm? Please reply me quickly. Yes, very good. Dhanashri, that's great. The expected input to this algorithm is an infix expression. And what is expected output? What is expected output? Expected output is postfix expression, right? Which is initially empty. Initially, kya hai postfix expression? Initially, postfix expression is empty, right? Okay, now I have written algorithm over here, right? Step 1, step 2, step 3, step 4. There are 4 steps total, right? Now, I'm going to take this example. I'm going to trace you. With example, I'm going to teach you how this algorithm works, right? Okay, so what is the first step, guys? First step is saying start scanning infix expression from left to right. So can you please tell me which will be the first element we're going to read? What will be the first element in infix expression? If we start scanning from left to right, so A will be the first element. And if you go by sequentially, after A, yes, multiplication operator is there, then B is there, slash is there. It means in this expression, there are only 2 possibilities. Either current element is an operand or, yes, it is an operator. Either operand or operator, right? So what is the first step? Start scanning infix expression from left to right, right? Now, while scanning, if current element is an operand, then what to do? Append it into postfix expression. It means here we have empty postfix expression, right? उसमें क्या करना है? मुझे append करना है, right? So what is A? Operand or operator? What is A, guys? Please reply me. What is A? Operand or operator? Yes, very good. It is an operand. So if it is an operand, what to do? If current element is an operand, append it into the postfix expression. It means we need to append it into postfix expression. Initially, postfix expression is empty, right? Okay, then yes. Step number 3. Either if or else, na? Please check. Step number 2. Either if part get executes or else part get execute. Agar if हुआ है तो else keep होगा, right? Then step number 3. Repeat above steps till the end of infix expression. It means we need to repeat this step again. Go to the next element. Yes. Is current element is operand or it is an operator? It is an operator, right? So if it is an operator, if current element is an operator, yes, क्या करना है? Please check. If stack is not empty, it means we require one stack over here which is initially empty. Stack is initially empty and we want to maintain a stack for operators. हमें stack किसके लिए maintain करना है? We need to maintain stack for operators. Hello friends, are you with me? So initially stack क्या है? Empty, right? So here condition will get checked. If stack is not empty, sir, is stack is empty? Yes, stack is empty, and hence this condition is false. This condition is false. Stack is not empty. This condition is false, right? So if stack is not empty, then only we'll go for checking priority. But if stack is not empty, then this condition gets failed, और ये while loop यहाँ पे क्या होगा? Break होगा, and control will come over here for the next step. Push current element on the stack. So which is the current element? Hello friends, current element कौन सा है? Multiplication operator, right? Current element multiplication operator. So we need to push it onto the stack. We need to push it onto the stack. Are you with me, friends? Right? Then read next element. After star, what is there? After multiplication operator, what is there? B is there. So what is B? B is an operand. If it is an operand, what to do? If it is an operand, append it into postfix expression, right? Then read next. After B, which element is there? How many steps repeat करना है? Step 1, step 2, we need to repeat till the end of the string, right? So yes, division operator. It means current element is an operator. So if current element is an operator, what to do? If current element is an operator, check each stack is empty. Wait, each stack is empty. No guys, please check. Stack is not empty because in stack already multiplication operator is there. So stack is not empty. First condition is true. Stack is not empty. First condition is true. Then go for checking second condition. So what is the second condition? Is priority of topmost element. So which is the topmost element? Which is the topmost element? Please reply me. Which is topmost element? Multiplication operator. Is priority of multiplication operator is greater than or equal to priority of current element? Is the priority of priority of star is greater or equal to priority of division? Equal है. मतलब condition is true ना? Greater or equal to. It means both the conditions are true. So if both the conditions are true, control come inside while loop. What to do? Pop an element from the stack and append it into postfix expression. It means we need to pop it from the stack and append it into postfix expression, right? Again, next iteration of while loop. This while loop is not yet break. Next iteration. Again, check is stack is empty. Is stack becomes empty now? Yes, stack becomes empty, and hence stack is not empty. This condition false, or this statement is false. So now we know that in logical AND operation, if first statement is false, second statement checking gets skipped. Right? It means if stack is empty, comparison will not take place. So if stack is not empty, then only we can go for comparing elements or comparing priority of operators. So stack is empty, it means this condition is false, and hence while loop gets break. Control come over here. Yes, what is the step? Push current element onto the stack. It means ये क्या करना है? ये stack में push करना है. Push current element onto the stack. Right? Again, repeat. Next, after division operator, next element is after division operator, next element is C. So what is C? C is an operand. Now, if it is an operand, what to do? If current element is an operand, append it into postfix expression, right? Read next. Next element is an operator, right? So if current element is an operator, then first check each stack is empty. Hello friends, each stack is empty. No, stack is not empty. So if stack is not empty, let me write over here. If stack is not empty, right? मैं आपका understanding के लिए यहाँ पे लिख रहा हूँ ऐसे. If stack is not empty, then only go for checking parity. Then only check for parity. Stack is not empty, condition is true. First condition is true. Then control go for checking second condition. Priority of topmost element is greater or equal to priority of current element. Is priority of division is greater or equal to? Yes, equal to A. What it means? It means both the conditions are true. Hello friends, are you getting what I'm saying? Both the conditions are true, right? Both the conditions are true. If both the conditions are true, then what to do? Hello guys, then what to do? Then we have to pop an element from the stack and append it into yes postfix expression. It means we need to pop it and append it into postfix expression, right? Then again, while loop is not yet terminated. Control go for next iteration. Right? Okay, just a minute. Let me write like this. Hello friends, are you getting what we are doing? Right? Then what next? Again, condition will check. If stack is not empty, if stack is empty. Each stack is empty now. Yes, stack is empty, and hence first condition is false. And hence second condition checking gets skipped. Control come outside for while loop. Push current element onto the stack. So which is the current element? Which is current element? Multiplication operator. Push it onto the stack. Right? Then again repeat next. Go to the next element. After multiplication, what is there? D is there. So what is D? D is an operand. If it is an operand, what to do? If current element is an operand, append it into postfix expression. Right? Read next. Current element is an operator. If current element is an operator, what to do? First check is stack is empty. No, stack is not empty. So if stack is not empty, then only go for checking second condition. Is priority of topmost element is greater or equal to priority of current element? Is the priority of multiplication operator is greater than or equal to priority of addition operator? Yes, greater hai. And hence both the conditions are true. And control come inside the while loop. Pop element from the stack and append it into postfix expression. Right? We say pop karna and append it into postfix expression. Right? Again, next iteration of while loop. Still while loop is not yet breaked. Right? Okay, again condition will get checked. First condition, is stack is empty. Yes, stack is empty. So if stack is not empty, this condition fails. If stack is not empty, then only we can go for checking parity. But if stack is empty, while loop gets break. While loop gets break and push current element onto the stack. Right? It means this plus will get pushed onto the stack at top. Are you with me, friends? Then after plus, what is there? After plus, E is there. What is E? Operand or operator? E is an operand, right? And hence we're going to append it into postfix expression. Read next. Division operator. So if current element is an operator, then check is stack is empty. No, stack is not empty. If stack is not empty, then check is priority of topmost element is greater or equal to priority of current element? False. Hello friends, this condition is false. Priority of topmost element, priority of addition, is a priority of addition operator is greater than or equal to priority of division operator? No, and hence second condition gets false. Second condition false hoga, and hence while loop gets breaked. Control come over here, push current element onto the stack. It means division operator will get pushed onto the stack at top position, right? Then after division, read next. After division, read next. F is there, right? So if current element is an operand, append it into postfix expression. After F, what is there? Minus is an operator, so it is a subtraction operator. So if current element is an operator, what to do? If current element is an operator, check is stack is empty. Well, check karo, is stack is empty. No, stack is not empty. If stack is not empty, then check is priority of topmost element, is it greater or equal to priority of current element? Topmost element is division operator. So is priority of division operator is greater than or equal to priority of addition, subtraction operator? Yes, greater hai. And hence both the conditions are true. Control come inside while loop, pop an element from the stack and append it into postfix expression. Right? Again, yes, next iteration of while loop. While loop next iteration. Again, it will get check is stack is empty. No guys, please check stack is not empty. If stack is not empty, then check is priority of topmost element is greater or equal to priority of current element. Priority of topmost, that is plus, is priority of addition operator is greater or equal to priority of subtraction operator? Yes, equal hai. And hence both the conditions are true. If both the conditions are true, control come inside while loop, pop an element from the stack and append it into postfix expression. Right? Again, next iteration of while loop. Again, we will get checked. Is stack is empty? Yes, guys, please check. Now stack becomes empty, and hence first condition is false. If first condition is false, second condition checking gets skipped. Control come outside while loop. While loop gets breaked, and push current element on the stack. So which element will get pushed on the stack? Subtraction operator will get pushed on the stack. Right? Then after minus, what is there? G is there. So what is G? Operand. So if current element is an operand, what to do? If current element is an operand, append it into postfix expression. Right? Read next. Is it there anything? Is there anything after G? No, it means infix expression scanning is finished. Infix expression scanning is finished. तो हमें step 1 step 2 repeat कब तक करने थे? We need to repeat step 1 step 2 मतलब हमें scan कब तक करना था? End of infix expression, and then what is the final step? Pop remaining elements from the stack and append them into the postfix expression. So how many number of elements are there? Only one element is there, right? So pop it and append it. Pop it and append it into postfix expression. Sir, is this the expected output? Is this expected output? Please check. यहाँ पे आंसर है देखो. Hello friends, can you see answer over here? एक मिनट. ये आंसर नहीं है, just a minute. ये दूसरा एक्सप्रेशन है. हाँ, ये आंसर देखो. ऑन पेपर जो हमने निकाला था. Whatever answer we found on paper, yes, is this the same? Please check, guys. AB star C slash D star EF slash plus. It means algorithm is working fine. Hello friends, have you understood algorithm? Have you understood algorithm? Believe me, algorithm is not difficult. वही step repeat करना है फिर से. So this is algorithm for, yes, this is an algorithm to convert given infix expression into its equivalent postfix. Is that fine? Is that fine, friends? Okay, now can we move to the next algorithm? Next algorithm will want to again remain same with some few changes in first one, right? Okay, so let me copy this as it is. Let me copy this as it is. तो जो लोग लेट ज्वाइन हुए उनके लिए ये रिपीट, ये रिवीजन है, right? Because first algorithm and second algorithm are almost same. दोनों क्या है? Same ही है. Just you need to know the difference. You need to just note difference. So algorithm number 2, conversion of given infix expression into its equivalent prefix, right? So this is our given input, infix expression, right? So what is expected output? What is expected output? Prefix expression. Expected output is prefix expression, which is initially empty. Again, in this algorithm, we're going to maintain stack of operators. In this algorithm, we're going to maintain stack of operators. Are you getting what I'm saying, guys? Okay, now what algorithm says? Pay attention. Algorithm says first difference, start scanning infix expression from, yes, right to left. Hello guys, have you understood first difference? In infix to postfix, we scan from left to right. In infix to prefix, we scan from right to left, right? Then if current element is an operand, again this point remains same. Append it into the prefix. यहाँ पे सिर्फ post की जगह पे क्या आएगा? Pre आएगा. So if current element is an operand, append it into the prefix expression. But if current element is an operator, what to do? Please check. If stack is not empty and priority of topmost element is only greater than, ये दूसरा difference है. यहाँ पे equal to नहीं, यहाँ पे सिर्फ क्या है? Greater than. So if priority of topmost element is greater than priority of current element, then only what to do? Pop element from the stack and append it into prefix expression. Otherwise, push current element on the stack. Right? That's it. सब पूरा का पूरा मतलब algorithm same है, right? Then repeat above steps till end of infix expression right? Then pop remaining elements from the stack and append them into the prefix expression. और यहाँ पे जो final step है वो आप मुझे बताओगे बाद में. We'll see it later. Only this much difference is there, right? So shall we start, guys? Shall we start? Pay attention. Okay, so what algorithm says? Algorithm says start scanning infix expression from right to left. So will you please tell me which will be the first element? Which will be the first element that we'll want to scan? Yes, G. Yes, what it is? An operand or operator? It is an operand or operator. Yes, it is an operand. If it is an operand, what to do? If current element is an operand, append it into prefix expression. उसे prefix में क्या करना है? Append करना है. Read next. Plus is an operator. Sorry, minus subtraction operator. So if current element is an operator, what to do? Check is stack is empty. Hello friends, is stack is empty? Yes, stack is empty. It means first condition is false. If stack is not empty, a condition false हुआ, and hence while loop gets break. And control come over here. Push current element onto the stack. It means this subtraction operator will get pushed onto the stack at top position. Right? Then go to the next element. Yes, next element. F. Sir, what is F? F is an operand. So if current element is an operand, what to do? Append it into prefix expression. Then read next. Division operator. If current element is an operator, then check is the stack is empty. Hello friends, is stack is empty? No. If stack is not empty, then go for checking priority. Is priority of topmost element is greater than priority of current element? Is the priority of subtraction is greater than priority of division? No. And hence second condition is false. While loop gets break, push current element on the stack. This element will get pushed on the stack at top. This element will get pushed on the stack at top. Are you there, guys? Right? Then after division, which element is there? E is there. Right? So what is E? E is an operand, and hence we're going to append it into prefix expression. Right? After E, what is there? Plus is there. So what is plus? Plus is an operator. If current element is an operator, what to do? Check is stack is empty. No, stack is not empty. If stack is not empty, then only go for checking priority. Is priority of topmost element? Is priority of topmost element is greater than priority of current element? Yes. Priority of division operator is greater than priority of addition operator. Addition operator, and hence both the conditions are true. Control come inside while loop, pop an element from the stack and append it into prefix expression. So ये element pop करना है, right? And will get appended into prefix expression, right? Then again while loop का next iteration. Again check is stack is empty. No, stack is not empty, guys. Please check. If stack is not empty, go for checking its priority. Is priority of topmost element is greater than priority of current element? No, priority of subtraction and addition दोनों का सेम है, मतलब ये कंडीशन यहाँ पे false हुआ. And hence while loop gets break, push current element onto the stack. It means this plus will get pushed onto the stack. ये क्या होगा? stack में push होगा, right? Then after plus, what is there? After plus, D is there. So what is D? D is an operand, and hence we're going to append it into prefix expression. Read next. After D, multiplication operator is there. If current element is an operator, then check is stack is empty. First, is stack is empty? No, stack is not empty. If stack is not empty, then check. If stack is not empty, then only check the priority. Is the priority of topmost element is greater than priority of current element? No. Priority of, yes. No means here condition false हुआ. Very good. Condition is false. So priority of addition is less than, and hence this condition gets failed, मतलब false, and while loop gets break. And hence control come over here. Push current element onto the stack. Current element क्या होगा? stack में push होगा at top. Right? Then read next. After star, what is there? After star, C is there. So C is an operand. If current element is an operand, what to do? Yes, append it into prefix expression, right? Then read next. Division operator. If current element is an operator, then check is stack is empty. No, stack is not empty. If stack is not empty, then check is priority of topmost element, that is priority of multiplication operator, is it greater than priority of current element? No, and hence second condition is false, and hence while loop gets break. Control come over here. Push current element on the stack. It means this element will get pushed onto the stack at top, right? Then read next. So next element is B. What is B? B is an operand, and hence append it into prefix expression. After B, what is there? Multiplication operator is there. If current element is an operator, what to do? First check is stack is empty. No, stack is not empty. If stack is not empty, then check is priority of topmost element is greater than priority of current element. No, दोनों का priority same है, and hence condition is false. Second condition false हुआ यहाँ पे because priority दोनों का same है. Is priority of division is greater than priority of multiplication? No, and hence condition is false. So while loop gets break and this element will get pushed onto the stack. ये element क्या होगा stack में push होगा. After star what is there? After star what is there? A is there. So what is A? A is an operand and hence element will get popped into prefix expression. Read next. Is there anything after A? No. It means that we need to do this step, repeat this step till the end of infix expression. Now, as soon as infix expression is finished, what to do? Pop element from the stack one by one and append them into prefix expression. Pop element from the stack one by one and append them into prefix expression. Hello friends, are you getting what I'm saying? Right? So we have finished with these steps, right? Now what do you think? What should be the last step? Pop remaining elements one by one from the stack and append them into the prefix expression. Yes. Last step क्या होना चाहिए? What should be the last step, guys? Last step, yes. Reverse करो. Reverse prefix expression or reverse expression. Reverse prefix expression. That will be the final answer. You will get final answer. Right? Okay. So if you reverse it, अगर आप इसे reverse करोगे, अब बोलो क्या आएगा आंसर? Minus plus star slash star A B C D slash E F G. Right? So this is what prefix expression, right? Okay, so we'll check. अरे हम confirm करते हैं. We'll confirm with the given answer. जो हमने पेपर पे निकाला था. Given मतलब whatever answer we found on paper. Infix to prefix जो हमने निकाला था आंसर. इसे क्या करते हैं? Compare करते हैं. Copy. Let me copy it from there and paste it over here. Hello friends, can you see the output? Minus plus star slash star ABCD slash EFG. Are we getting the answer, guys? Are we getting the answer? Right? And hence, yes, this is how we can convert given infix expression into its equivalent prefix, right? So infix to postfix and infix to prefix, both algorithms are exactly same, just only few 2-3 differences. Hello friends, is that fine? Is that fine? Navjot, आपने repeat करने के लिए बोला था. I guess you joined late, right? Now for repetition, you can refer recorded video because मैंने ये 3 बार repeat किया, right? And every step is repeated after some, मतलब हर step repeat हो रहा है, right? So for you can refer recorded session अगर आप late join हुए हो तो. हाँ, लेकिन अगर आपको समझ में नहीं आया तो मैं आपको बता सकता हूँ फिर से. You can explicitly ask your doubt. So what type of question ask in CCAT? Don't worry. आपका इसके ऊपर टेस्ट होगा and I'm going to share questions with you. You will get idea. Don't worry. Questions will get asked purely depend upon concepts. Whatever we learn now. हार्दिक, जो भी हमने यहाँ पे concept algorithm पढ़े उसके ऊपर question आएंगे. Don't worry. Have you understood algorithms? Yes. So don't worry. You will be able to solve the questions. Right? Now can we move to the next algorithm, guys? Can we move to the next algorithm? That is algorithm. Yes. Algorithm number 3. Algorithm number 3. Yes. Conversion of. Okay, not conversion of. Here we can say, sir, we write algorithms as per our requirements. No, हम लोग algorithm सीख रहे हैं. आपको algorithm नहीं लिखना है. देवीदास, आपको खुद से algorithm नहीं लिखना है. You have to, yes, you have to follow the same algorithm. You have to follow same algorithm. You don't have to write any algorithm. आपको कोई भी algorithm नहीं लिखना है. आपको ये algorithm पढ़ना है सिर्फ जो है वो. Right, देवीदास? You don't have to write any algorithm as it is पढ़ना इसको. Okay, now we are moving to the next algorithm. Yes, postfix evaluation. Algorithm for postfix evaluation. Right? Okay, it means very first, if you want to apply this algorithm, yes, expression must be of which type? Hello friends, if we want to apply this algorithm, expression must be of type postfix. No, it must be of type postfix. Right? It means if we are having infix expression, so we need to first convert it into its equivalent postfix. अगर expression infix में दिया है तो उसे हमें postfix में convert करना पड़ेगा compulsory. Right? Okay, let me write first algorithm over here. Let's say 4. Sorry, let me first write expression 4 into 5 divided by 6 into 8 plus 9 divided by 3 plus 2. Hello friends, this expression is of which type? This expression is of which type? Infix. So can we apply this algorithm directly on this expression? No. So हमें क्या करना पड़ेगा? Very first. So why we reverse expression? अरे algorithm है ये. देवीदास, it is an algorithm. देखो algorithm apply करके हमें ये मिला आंसर, right? And this is the final step. Final step of algorithm, we need to reverse expression. And if we reverse expression, we'll get prefix expression. Is that fine? Okay. So it is an algorithm. हमें वो follow करना है. That's it. Right? Okay. Now, if you want to apply algorithm for postfix expression evaluation, right? And we are having infix expression, we have to first convert it into its equivalent. postfix, right? So how we can convert into postfix? We know that on paper. We know how we can convert given infix expression into its equivalent postfix, right? So which operation we can perform first? Hello guys, which operation we can perform first? This multiplication, right? Algorithm ask in exam, yes. Algorithm exam में पूछे जाएंगे. Algorithm exam में पूछे जाएंगे, yes. मतलब algorithm based question पूछा जाएगा. Questions which are based on algorithm, right? Okay, so very first we can perform multiplication between 4 and 5. तो इसका आंसर क्या आएगा? 4 5 star. Hello friends, have you understood result of first step? Result of first step, right? Yes, I'm going to share questions as well as आपका quiz भी होगा इसके ऊपर आपका quiz भी होगा. Don't worry. Okay, then pay attention. This is the first operand. This is the first operand or first term, second term, right? Third term, fourth term, fifth term, and sixth term. Now we can perform what? We can perform this division between these two. We can perform division between these two, right? So what will be the answer, guys? What will be the answer? 4 5 star 6 slash. Rest of expression remains as it is, right? Now in next step we can perform multiplication between 4 5 star 6 slash and 8. In दोनों का multiplication होगा. This operation can be performed, right? So what will be the result? Result will be, yes, operand 1, right? Then operand 2 and an operator. So this is the result of this step. Rest of expression remains as it is, right? Then we can perform which operation? We can perform this division operation, right? So what will happen? Division between 9 and 3. So 9 3 slash, right? So how many terms are there now? First term, second term, and third term. So addition, yes, addition. We can go from left to right because both are having same priority. So we can go from left to right. So answer of this step will be what? Yes, plus, right? And we can say plus 2. And finally, yes, finally we'll get result as this. Hello friends. So this is postfix expression of given infix expression, right? So for algorithm, for postfix expression evaluation, what will be input? Input will be what, guys? Input will be postfix expression. और वो हम इसको input pass कर रहे हैं. We are passing input, right? So what is output? Output is result. Expected output is result. तो ये result आना चाहिए, right? Now is it possible for you guys to calculate result on paper by assuming division of two integers is integer? Division of two integers is integer. ये assume करके आप इसका on paper answer निकालो guys. Quickly find the answer of this expression on paper. Just follow division of two integers will be integer only. Quick and give me the answer. Tell me the answer on the chat box. Tell me your answer on chat box quickly. Okay, Shubham is saying answer is 29. Okay, please note down this answer with you. Note down this answer with you. We'll confirm it. हम लोग ये confirm करने वाले अभी, right? कि whether algorithm is giving the same answer or not, right? Okay, so let me write algorithm over here. Step number 1, start scanning. Postfix expression from left to right. Step number 2, if current element is an operand, then yes, क्या करना है उसे? Push it onto the stack. उसे क्या करना है? Stack में push करना है. Push it onto the stack, right? Else, sir, what do you mean by else? Else, if current element is an operator. If current element is an operator, right? Sir, if it is an operator, what to do? Pop two elements, or can we say operands? Hello guys, what we are pushing on the stack? We are pushing operands on the stack, right? So what to do? If current element is an operator, pop two operands or two elements from the stack. In such a way, yes, first pop element will be the second operand. Yeah, algorithm है, right? And second pop element, and yes, second pop element will be the first operand, right? Then after popping these two elements, yes, perform current element, that is operation between OP1 and OP2, right? It means operand 1 and operand 2, right? So first pop element will be the second operand, that is OP2, and second pop element will be the first operand, that is OP1, right? Or sir, ये क्या है? Operator, that is OPR. Current element is OPR. Operator, operand 1, operand 2. So perform current element, that is OPR operation between OP1 and OP2, right? And push result back onto the stack. Right? Okay. यहाँ पे मैंने steps लिखे हैं guys. Don't worry, ये repeat होंगे with the example, right? And what is the last step? Last step is that. Last step नहीं है ये. Third step है. Repeat above steps till the end of postfix expression. Repeat करना है, right? And the last step, yes, pop final result from the stack pop final result from the stack, right? And return, and return, and return, right? Or we can say pop the final result from the stack, right? So this is algorithm. Don't worry, I'm going to show you this algorithm by tracing with an example, right? Okay, so initially what we required? Empty stack. Do you agree with this? Now we are maintaining stack of, hello friends, we are maintaining stack of operands. We are maintaining stack of operands. So stack is initially stack kya hai? Empty, right? So this is given postfix expression, right? Okay, what is the first step? Step number 1. Let me write current element over here, right? Yes, what is the first step? Start scanning postfix expression from left to right. So will you please tell me, guys, which element will be the first element? 4 is the first element, right? Is current element is an operand? Is an operand? Yes. So if current element is an operand, what to do? Push it on the stack. So sir, is 4 ko kya karna hai? We have to push it on the stack, right? Then read the next element. 5. So what is 5? Operand or operator? It is an operand. Again, push it on the stack. उसे भी stack में push करना है at top. Top में push करना है, right? Then read the next element. Read the next element. An operator, right? So current element is an operator, right? It is an operator. Multiplication operator. So if current element is an operator, what to do? Pop 2 elements from the stack in such a way that first pop element will be, yes, first pop element will be the second operand, right? It means value of first pop element will be the second operand, right? And second pop element will be the first operand. Hello friends, are you with me? So we have popped 2 elements from the stack in such a way that first pop element will be the second operand, second pop element will be the first operand. Then what to do? Perform, yes, OP1, OPR, and OP2. Perform this result. Sorry, perform this operation. Perform this operation between OP1 and OP2. So what is the value of OP1? Value of OP1 is 4. So what is OPR? Multiplication operator, and OP2 5, right? Perform this operation 4 into 5. What is the result, guys? 20, and hence perform current element operation between OP1 and OP2 and push result back onto the stack. So this result को फिर से क्या करना है? Stack में push करना है. Hello friends, are you with me? Right? Okay. Then next, after multiplication operator, what is there? Next element. Yes, 6. So what is 6? 6 is an operand, and hence push it on the stack. उसे stack में push करना है, right? After 6, what is there? After 6, division operator is there. If current element is an operator, please check here. Repeat. ये आपने repeat ही है because steps are getting repeated. If current element is an operator, what to do? Pop 2 elements from the stack in such a way that first pop element will be the second operand, second pop element will be the first operand. Hello friends, are you with me? Right? Then after popping 2 elements from the stack, yes, perform current element operation, मतलब division between OP1 and OP2. So what is the value of OP1? Value of OP1 is 20. OPR का value, division operator. OP2 का value 6. 20 divided by 6. Division of 2 integers will be integer. Result is 3. Push back result on the stack. Hello friends, have you understood this? Push back result on the stack, right? Then read next. After division operator, what is there? 8 is there. So what is 8? 8 is an operand. If it is an operand, what to do? Push it on the stack at top, right? Then read next. Next element is an operator. Next element is an operator. So if current element is an operator, what to do? Pop 2 elements from the stack in such a way that first pop element will be the second operand, second pop element will be the first operand, right? Then perform current element operation between OP1 and OP2. Value of OP1 is 3. Value of OPR is 2, and OP2 is 8. Result is 24, and hence push back result on the stack. Push back result on the stack, right? Then after multiplication operator, what is next? What is next? 9 is there, right? So what is 9? 9 is an operand, and hence push it on the stack. After 9, what is there? 3 is there. Again, 3 is an operand. Push it on the stack. Read next. Division operator. So if current element is an operator, what to do? Pop 2 elements from the stack in such a way that first pop element will be the second operand and second pop element will be the first operand. Then perform current element operation between OP1 and OP2, right? That is 9 divided by 3. Yes, 9 divided by 3. What is the result? Result is 3, and hence push back result on the stack. Push back result on the stack at top, right? Then after division operator, what is there? Plus is there. Addition operator is there. So if current element is an operator, what to do? Pop 2 elements from the stack in such a way that first pop element will be the second operand, second pop element will be the first operand, right? And then what to do? Perform current element operation between OP1 and OP2. So 24 plus 3, 27, and hence push back result on the stack at top, right? Then after plus, what is there? After addition, yes, 2 is there. So what is 2? 2 is an operand. If it is an operand, what to do? Push it on the stack, right? After pushing on the stack, yes, read the next element. Addition operator. If current element is an operator, pop 2 elements from the stack in such a way that first pop element will be the second operand and second pop element will be the first operand. Then perform, yes, current element operation between OP1 and OP2. So 27 plus 2, What is the result, guys? 29, and hence push back result on the stack. Push back result on the stack. After plus, what is there? Nothing is there, and hence postfix expression is finished. So what is the last step? Last step, pop final result from the stack. So we're going to pop final result from the stack. So this is the expected output. Hello friends, have you understood this algorithm? Have you understood this algorithm? Right? So this is how, yes, algorithm for postfix expression is there. Evaluation. Postfix expression evaluation is there. Is that fine? So you people can expect questions in CCAT depend upon these algorithms only. That's it. Once you have understood algorithm, then believe me, you will be able to 100% guarantee तुम्हें आपको, you will be able to solve any type of any question. I hope it is clear to all of you. I hope it is clear to all of you. Right? Okay. And now here we are finished with stack data structure. Right? Now we are moving to the next data structure. It is queue. Yes. Sir, any example of question? तुषार, मैं आपको question share करने वाला हूँ. I'm going to share questions with you. Right? Don't worry. और आपका टेस्ट भी होगा इसके ऊपर. So we can more focus on to learn next concepts. आगे के concept हम लोग focus करेंगे, right? Don't worry, it's my guarantee to all of you. Once you understood the concept, you people will be able to solve any question. अगर आपको concept समझ में आ रहे हैं, तो you will be able to solve any question. Don't worry. आपको practice question, आपका test रहेगा, test होगा, आपका quiz होगा, right? And I'm going to share questions as well with you, sample question. Don't worry. Okay. So can we start with the next now? Data structure Q, right? So what is Q? It is a basic linear data structure. It is a basic linear data structure, which is a collection of, yes, logically related, similar type of elements into which elements can be added from one end, referred as. Yes. Can anyone tell me the answer of this, guys? It is a basic linear data structure, which is a collection of logically related similar type of elements into which elements can be added from one end, referred as rear end. Very good. And elements can be deleted from another end, referred as, yes, front end. So Q data structure has got how many ends? Two ends, front and rear. So for addition of element, rear end is there, and for deleting element from it, front end is there. Right? Okay, now pay attention. In this list, right? So यहाँ पे either we can say collection or we can say list. मतलब collection or list of elements, right? Okay, in this list, element which was inserted first, yes, can be deleted first. So this list works in which manner? So this list works in, yes, first in, first out manner. Hello friends, have you understood this? In this list, element which was inserted first can be deleted first. So this list works in, first out, or can we say last in, last out? Hello friends, can we say either first in, first out, or last in, last out? And hence this list is also called as, yes, FIFO list, or last in, last out list. I hope you people have understood this. Hello guys, have you understood this concept and definition of Q data structure? Yes, stack works in last in, first out, Q works in, first out. Exactly. Stack has one end, Q has two ends. Is that fine? Right? Okay. Now here we can say we can perform basic two operations. We can perform basic two operations on Q data structure. We can perform basic two operations onto the Q. In how much time? Again in order of, yes, again in order of one time. So on stack data structure, we can perform how many basic operations? On data structure stack, how many basic operations we can perform? Three. Which three? Stack ke upar. On stack, we can perform basic three operations: push, pop, and pick. Whereas on Q data structure, we can perform only two operations. Number one is NQ, and number two is DQ. Number one is NQ, and number two is DQ. Hello friends, right? So these two operations we can perform on Q data structure, right? Okay. So what do we mean by NQ? To NQ means, yes, to insert or to add, or to push an element into the queue from rear end, right? Whereas or we can say into the queue at rear end, right? Then what do we mean by DQ? To remove or to delete or to pop. You can use any word. To remove or to delete or to pop an element from the queue, which is at front end. Hello friends, have you understood these two basic operations? So these two basic operations we can perform on Q data structure in how much time? ये भी important है. In how much time? Order of one time. Is that fine, friends? right? Okay, now first we'll see. Yes, total there are 4 types of queue. How many types of queue are there? Total there are 4 types of queue. Type number 1 is linear queue. Type number 2 is circular queue, right? So linear queue working manner is FIFO, first in first out. Circular queue working manner is FIFO only, right? But there is one more queue, type of queue, which do not works in first out manner. Which do not works in first out manner. Then sir, what it is? Pay attention. It is a type of queue. It is a type of queue in which elements can be added or can be inserted into the queue from rear end randomly. So what do you mean by randomly? That is without checking priority. Without checking priority of an element. Without checking priority, right? Whereas yes, an element which is having highest priority, can only be deleted first. From it. Hello friends, have you understood what do you mean by priority queue? So priority queue is a type of queue in which elements can be inserted into the queue, right? Into the queue from rear end randomly, that is without checking priority, whereas an element which is having highest priority can only be deleted first from it. Is that fine, guys? Hello friends, have you understood difference between linear, simple, we can say simple or usual queue data structure and priority queue, right? Okay, number 4. Now from CCAT point of view, pay attention guys. From CCAT point of view, just remember this point. Priority queue can be implemented. Only a point yaad rakho. That's it. From CCAT point of view, priority queue can be implemented by using linked list as well as binary heap, right? Linked list as well as binary heap, right? But here we can say, out of which binary heap we can say it is the most efficient, right? Or here we can say priority queue can be implemented by using linked list, right? And it can be implemented efficiently by using binary heap, right? So please remember this point only, that's it. So priority queue can be implemented by using linked list, right? And yes, it can be implemented efficiently by using binary heap as well. Is that fine? So just remember this point from exam point of view, CCAT point of view, right? Okay, then we are moving to the next type of queue, that is double-ended queue. So ये क्या होता है? Double-ended queue is also called as DEQUE, double-ended queue. Hello friends. So if you look at carefully, DEQUEUE, spelling DQ, this is a basic operation that we perform onto the queue data structure, whereas double-ended, D stands for double, E stands for end, DEQUE, DQ, it is a type of queue. Have you noted difference between spelling, number of characters in it? So ये difference है, right? Please note this. So what is DQ? It is a type of queue in which elements can be added as well as deleted from both the ends. It is a type of queue in which elements can be added as well as deleted from both the ends. Double-ended queue. Is that fine? And hence we can perform yes, basic 4 operations on DQ in how much time? In order of 1 time. So which 4 operations? Number 1, yes, is push back. Number 2 is yes, pop back, or we can say push front. Push back, push front, pop back, pop front. Hello friends. So these are the 4 basic operations that we can perform on DQ data structure, right? And please note one point. Yes, DQ can be implemented yes, efficiently. Can be implemented efficiently by using yes, doubly circular linked list. Hello friends, कल हमने डिस्कस किया था doubly circular linked list. Yes, at first, delete first. These operations can be performed in how much time? On doubly circular linked list. On doubly circular linked list, these operations can be performed in how much time? Hello friends, please reply me quickly on the chat box. On doubly circular linked list, these operations can be performed in how much time? Order of 1 time, right? And hence we can say DQ can be implemented by using doubly circular linked list, right? Or we can say, yes, it can be implemented by using doubly linear linked list with head and tail pointer. tail pointer, right? It means W linear linked list also can be implemented with tail pointer. So head pointer will always store address of first node, tail pointer will always store address of last node. Hello friends, are you getting what I'm saying? तो मैं exam point of view मैंने यहाँ पे लिख के रखा आपके लिए. So just remember this. From CCAT point of view, just remember this, right? So if we use head and tail pointer for W linear linked list, then only it takes order of one time for add last, add first, delete last, delete first. Is that fine? Hello friends, have you understood these 4 types of linked list? Okay, one more point. There are 2 types of DQ. There are 2 types of DQ. So which 2 types? Yes, number 1 is input restricted DQ, and number 2, yes, number 2, any guess? Output restricted DQ, right? So what do you mean by input restricted DQ? It is a type of DQ. It is a type of DQ in which yes, elements can be added, yes, or can be deleted from both the ends. Can be deleted from both the ends, but can be added. Elements can be added only from one end. Hello friends, have you understood what do you mean by input restricted? So input restricted DQ, it is a type of DQ in which elements can be deleted from both the ends, but can be deleted only from one end. I hope you people have understood this, right? Whereas, so what do you mean by output restricted? It is a type of DQ. Yes, in which elements can be added from both the ends. But can be deleted from only one end, or only from one end. I hope you people have understood difference between input restricted DQ and output restricted DQ. Vice versa मत बोलो यहाँ पे, right? अलग से definition लिखा मैंने, input के लिए अलग से लिखा है, इसके लिए अलग से लिखा है. Have you understood, right? Concept समझ में आया? Okay. Now we'll see exactly how these operations can be, these algorithms, कौन से algorithms? NQ and DQ works, right? Operations NQ and DQ, right? Okay, so let us come to this point, guys. Pay attention. So linear queue can be implemented by using an array. So can you see this array, guys? Can you see this array in front of you? What is size of array? What is the size of array? Size of array is 5, right? Size of array is 5, right? So this array will want to use as what? This array will want to use as a linear queue. Hello friends, are you getting what I'm saying? Whatever diagram of an array you can see over here, this array will want to use as a linear queue. So array has what? How many ends? 0, 1, 2, 3, 4. These are the indices of an array. तो सर ये जो array के indices है, हम उसको मैप करेंगे front and rear, which are ends, 2 ends of queue, Hello friends, are you with me? Right? So what you think? What should be the initial value of front and rear? Like stack. जैसे stack में, pay attention. Like stack, value of top is initially -1. Similarly, initially, what should be the value of front and rear initially? 0 or -1? No, guys, not 0. Not 0, because if the value of rear is 0, it indicates yes, already there is one element, because array indexing in array 0 is valid index, right? And hence initially value of front and rear are -1. Initially value of front and rear are -1. Hello friends, are you getting what I'm saying? Right? Are you getting what I'm saying? Right? So can we say over here, yes, sir, when we can say Q is empty, we can say Q is empty if value of rear is equal to -1. Right? If value of rear is equal to -1, as of now, can we say Q is empty? Yes, right? And so what about Q full? ठीक है, Q full का हम लोग बाद में देखते हैं. So we check these conditions later. So as of now, can we say if value of rear is equal to -1, Q is empty, right? तो rear का value initially क्या होगा? Rear का value होगा initially -1, front का value होगा initially -1. Hello friends, are you with me? Right? -1. So we can perform how many operations on the queue? We can perform how many operations on the queue? 2 operations. So which 2 operations? NQ and DQ, right? Okay, now we first start writing algorithm. Step number 1. If you want to insert element, NQ means what? Insert element, right? So if you want to insert element into the queue, what do you think? What should be the first step? What do you think? What should be the first step? Now, as we are implementing queue by using an array, so we know that array has upper limit. Hello friends, like a stack, जो हमने array use करके implement किया था. So like a static stack or stack by using array, here as well we are implementing queue by using array. So is there upper limit? Yes. And hence, while inserting element into it, step number 1, we have to check Q is not full. Hello friends, are you getting what I'm saying? Full, empty nahi, full, right? While inserting, right? So here we can say if Q is not full, then only we can insert an element into it. Do you agree with this, friends? Do you agree with this first step? Right? So what is step number 1? Step number 1 is check stack is not full, right? So as of now by diagram, can we say stack is not full? As of now by diagram, can we say stack is not full? Yes, we can say stack is not full, right? Then what should be the second step? Step number 2, yes, from which end we can insert element? We can insert element from rear end. So but what is the value of rear currently? Value of rear is -1, and hence if you want to insert element into the queue from rear end, we need to increment the value of rear by 1. Do you agree with this? What is the second step? Increment the value of rear by 1. Increment the value of rear by 1. So sir, value of rear will become, if we increment by 1, it will become 0, right? And hence instead of writing 0 over there, can I move it from here to here? Can I move rear from here to here? Which indicates value of rear is 0. Value of rear is 0, right? Then what next? What next step? Next step, yes, insert an element. Insert an element into the queue. At which end? Or from which end? From rear end. Insert an element into the queue from rear end, right? It means, let's say for example, अरे हम लोग यहाँ पे कौन सा भी वैल्यू ले रहे हैं, let's say 111. Let's say 111. So at rear end हमें क्या करना है? इसे insert करना है. So ARR of rear में हम क्या करेंगे? इसे insert करेंगे. Hello guys, are you getting what I'm saying? Right? It means let me write statement over here, right? ARR of rear is equal to an element. Hello friends, is that fine? Is that fine? Rear right hand side of queue. No, wait, don't conclude too fast. Sir, can you please expand which is front and rear end? These are the two ends of the queue data structure. Front and rear, these are two ends of queue data structure. अगर आप यहाँ पे definition देखोगे, देखो queue का, मैंने यहाँ पे definition लिखा है. So queue is a basic or linear data structure in which from one end we can insert element from rear end, and from front end we can delete element. Is that fine, Devidas? So queue data structure has two ends, rear and front. Is that fine? Okay. Okay, so from rear end, what we did, we have inserted an element into the queue, right? Now pay attention. Pay attention. Sir, एक ही element insert किया user ने. Now is it possible that user want to delete same element? Is it possible for the user want to delete same element? Yes. Hello friends, are you with me? So if there is one element inserted onto the queue, so is it possible that user want to delete that same element? Yes, it is very much possible, right? And hence, from which end element can be deleted? From which end element can be deleted? Yes, front end. So but what is the value of front right now? Value of front right now is, yes, -1. So it should be what? It should be what? It should be 0. It should be at 0th position, right? And hence we'll write step number 4 over here. We write step number 4 over here. If yes, value of front is equal to -1, then make it as, yes, make it as 0. Then front is equal to 0. Hello friends, are you with me? So this is the fourth step, right? So is value of front equal to -1? Yes, value of front is -1, and hence we need to make it as, हमें वो value क्या करना है? 0 करना है. हमें value क्या करना है? वो 0 करना है, so that from this front position element can be deleted. This element can be deleted. Hello friends, have you understood so far? Have you understood so far? Right? So these are the 4 steps of which algorithm? These are the 4 steps of NQ algorithm. Now pay attention. I want to insert one more element onto the queue. I want to insert one more element into the queue. What is first step? Again, apply algorithm. What is first step? Step number 1, check queue is not full. By diagram is queue is full. By diagram is queue is full, friends. No, by diagram queue is not full, right? And hence we can go to the second step. What is second step? Second step, increment the value of rear by 1. Can you please tell me guys, currently what is the value of rear? Currently what is the value of rear? Value of rear is 0. So if we say increment by 1, it will become, if we say increment it by 1, it becomes 1. It becomes 1, right? Then go to the third step, insert an element into the queue from rear end. So at rear end means at which end? Rear end means at which end? Yes, rear end means at, yes, first position. So sir, कौन सा element insert करना है हमें? Let's say for example 222. Let's say for example 222, insert it into the queue at rear end. Hello friends, so value of front is 0, value of rear is 1. So total, how many number of elements are there right now in a queue? In a queue, how many number of elements are there? 2 elements are there, right? Now please, again, fourth step, is the value of front is equal to -1? Is value of front is equal to -1? No, so it remains 0 only. वो जो है वही रहेगा, right? Okay, I want to insert one more element. Again, apply algorithm. If you want to insert element, apply algorithm step by step. First step, check queue is not full. By diagram is queue is full. By diagram is queue is full. No, by diagram queue is not full, right? And hence we can go to the second step. If queue is not full, then only we can insert an element into the queue. Second step, increment the value of rear by 1. So currently, what is the value of rear? 1. If we increment it by 1, it becomes, it becomes, yes, it becomes 2. It becomes 2, right? Then third step, insert an element into the queue from rear end. That is at second position, right? कौन सा element insert करना है? Yes, next element, let's say 333. Let's say 333, we inserted into the queue at rear end. Then fourth step, Step number 4, is value of front is equal to -1? No, value of front is 0. So it remains 0 only, or it remains whatever it is. जो है वही रहेगा value. Now I want to insert one more element. Again, follow algorithm. Step by step. Check Q is not full. By diagram, is Q is full? No, by diagram, Q is not full. Go to the second step. Increment the value of rear by 1. So value of rear becomes 3. Third step, insert an element into the queue from rear end. So at rear end, we'll insert element, right? Let's say, for example, value of element will be 444. So 444, this value will get inserted into the queue at which end or from which end? From rear end. Step number 4, is the value of front is equal to -1? No. So it remains whatever it is. I want to insert one more element. Again, is Q is full? No, Q is not full. We can go to second step, increment the value of rear by 1. Increment the value of rear by 1. Third step, insert an element into the queue from rear end. Let's say value of element is 555, and 555 will get inserted into the queue at which end? At rear end, right? At rear end. Is value of front is equal to -1? No, it remains as it is. Now, if I want to insert one more element, first step, check Q is not full. By diagram, is Q is full? Yes, by diagram, Q is full. It means, sir, when we can say Q is full? Condition. When we can say Q is full? If the value of rear is equal to size -1. Hello friends, are you with me? If value of rear is equal to size -1, in that case, we can say Q is full. Hello friends, have you understood Q full condition? Have you understood Q full condition? Right? Now, can we move to the next function, DQ? Can we move to the next function, DQ? Hello guys, I hope you people have understood NQ operation. I hope you people have understood NQ operation, right? Now we are moving to the next operation, that is DQ. That is DQ operation, right? Now, what do you think? What should be the first step? Yes, first step, we have to check that Q is not empty. Very good. Q is not empty. So if Q is not empty, then only we can delete element. Then only we can delete element from it. Hello friends, do you agree with this? Right? Then step number 2, pay attention. Okay, if you want to delete element from the queue, what is step number 1? Check Q is not empty. So by diagram, is Q is empty? By diagram, is Q is empty? No, by diagram, Q is not empty. By condition, is value of rear is equal to size, is value of rear is equal to -1? No, it means by condition as well, Q is not empty. So sir, hame element, we can delete element from which end? We can delete element from which end? From front end, right? So which element should get deleted first? 111. First in, first out. We know that Q data structure works in which manner? First in, first out. So which element was inserted first? 111. Sir, after deletion of 111, which element should get deleted? Or which element was inserted after 111? 222, right? And hence after 111 deletion, yes, 222 should get deleted. After deletion of 222, 333 should get deleted. And hence, if you want to achieve this first in, first out working manner, then we need to increment the value of front by 1. Hello friends, are you getting what I'm saying? हमें यहाँ पे क्या करना पड़ेगा? हमें फ्रंट का वैल्यू इंक्रीमेंट करना पड़ेगा. हमें फ्रंट का वैल्यू क्या करना पड़ेगा? इंक्रीमेंट करना पड़ेगा. हेलो गाइस, आर यू गेटिंग व्हाट आई एम सेइंग? ओके सर, प्लीज बताइए किस साइड से इंसर्ट एंड डिलीट? अरे फ्रंट, फ्रॉम रियर वी कैन इंसर्ट, फ्रॉम फ्रंट वी कैन डिलीट. राइट लेफ्ट ऐसा कुछ मत सोचो. फ्रंट एंड एंड रियर एंड, टू एंड्स. पवन, इज दैट फाइन? सो देयर आर टू एंड्स फॉर क्यू डेटा स्ट्रक्चर, फ्रंट एंड एंड रियर एंड. ऐसे राइट लेफ्ट उसको कंसीडर मत करो. इज दैट फाइन? Is that fine? So please first try to understand algorithm, whatever I told you over here, right? Okay, now step number 1, check Q is not empty. So by diagram, is Q is empty? By diagram, is Q is empty? No, by diagram, Q is not empty. By condition, is the value of rear equal to -1? By condition as well, Q is not empty, right? And hence we can go to second step. Now in this case, we need to increment the value of front by 1, right? And hence I will write over here, increment the value of front by 1. Hello friends, so what we'll do over here, we're going to increment value of front by 1. हम यहाँ पे क्या करेंगे? फ्रंट का वैल्यू 1 से इंक्रीमेंट करेंगे, right? And hence by means of incrementing value of front by 1, yes, that is what we are doing. We are, yes, deleting element, deleting an element. We are deleting element from the queue. Hello friends, have you understood this? So by means of incrementing value of front by 1, what we are achieving? We are deleting element from the queue. It means that this element got deleted. ये एलिमेंट क्या हुआ यहाँ से? This element got deleted from the queue. Are you with me, friends? Are you getting what we are doing? Right? Hello, friends. Are you getting what I'm saying? Right? So we have deleted one element from the queue. Right? Now, please check. I want to delete one more element from the queue. Again, can we apply algorithm? If we want to delete element from the queue, yes, apply algorithm. Right? Step number 1. Check Q is not empty. So by diagram, is Q is empty? By diagram, is Q is empty? No, by diagram, Q is not empty. Right? So we can go to the second step. So by condition as well, please check, is value of rear equal to -1? By condition as well, Q is not empty. Right? So can we go to the second step? Yes, second step, increment the value of front by 1. Right? So value of front will become 2, and hence by means of incrementing value of front by 1, we have deleted one more element from the queue. We have deleted one more element from the queue. Now, can you please tell me, guys, how many number of elements left in a queue now? 3 elements. How many elements? 3 elements. Our elements are getting deleted in first out manner. Our elements are getting deleted in first out manner. Yes. Now, if I want to delete one more element from the queue, again follow algorithm. Step number 1, check queue is not empty. Check queue is not empty. So by diagram, is queue is empty? No, by diagram, queue is not empty. By condition, is the value of rear equal to -1? By condition, is the value of rear equal to -1? No. And hence, by condition as well, queue is not empty. Hello friends, are you getting what I'm saying? By diagram as well as by condition, queue is not empty. And hence, we can go to the second step. What is the second step? Increment value of front by 1. So what is the current value of front? Current value of front is 2. After incrementing it, it becomes, yes, it will become 3. वो क्या होगा? Value front का 3 होगा. And hence, by means of incrementing value of front by 1, what we have achieved? Yes, we have achieved deletion of one more element from the queue. We have achieved deletion of one more element from the queue. Hello friends, right? Are you there? So don't you think we can delete one more element from the queue by same way, right? So first, is queue is empty? No, queue is not empty. Then increment the value of front by 1. By means of incrementing value of front by 1, we are deleting one more element. Again, if I want to delete one more element from the queue, step number 1, check is queue is empty? Is queue is empty? No. By diagram, queue is not empty. By condition, is value of rear equal to -1? No. What to do? Next step, increment value of front by 1. So value of front will become, बोलो front का value क्या होगा? 5 होगा. Very good. Value of front will become 5. Value of front will become 5 in this case, right? Value of front will become 5. It means we have deleted one more element from the queue. Now pay attention. If we try to delete one more element, from the queue, yes, step number 1, check queue is not empty. By diagram, is queue is empty? By condition, is the value of rear equal to -1? No. It means, don't you think, guys, this condition fails? This condition is not sufficient. To check queue is empty or not. And hence, we need to add one more condition over here. So condition क्या लिखेंगे? Please check. If front crosses rear, ये condition यहाँ पे लिखेंगे. Hello friends, are you getting what I'm saying? And hence here we can say, or